Hello all, my name is Neha Lad. This is my final project presentation for AIT 582. This project is related to Airline Dataset. So the project basically deals with Airline A. Airline A is responsible to maintain a customer database, and the database has below attributes like customer ID, fare, guest, seat class, success and description. So customer ID is a unique ID that is associated with the customer. Fare is the total amount paid by the customer for traveling with Airline A. Guest is the number of guests that are accompanying the customer for the airline travel. Seat class is something that is chosen by a customer and it lies within the range of 1, 2 or 3. Success is if a customer has decided to travel by the airline or has he decided to cancel it. Description is containing the details of the customer. The main aim of the project is to provide an analysis of airline dataset. That is, basically it identifies if a customer will fly or will not fly with airline A. It basically deals with metadata extraction and using the extracted data for generating model to perform classification. It predicts the success rate of customer flying with the airline. The findings are then supposed to be shared with the advertising team, which in turn will build customer demographic specific packages so that they can attract more and more number of customers. To attain the objective, 5 milestones are created for the project as below. First, data acquisition and conversion. Second is metadata extraction and imputation. Third is metadata exploration. Fourth is attribute preparation and engineering for preparing for mining algorithm. Fifth is prediction, modeling and visualization. So the tools used to carry out this analysis is Python and Vika. So the first 3 milestones, that is data acquisition and conversion, metadata extraction and imputation, metadata exploration, is carried out in Python, and attribute preparation and engineering for preparing for mining algorithm, and prediction modeling and visualization is done in Vika. So the first milestone is data acquisition and conversion, and it consists of 3 steps. So the first step is data downloading. The given customer airline dataset is available in JSON format and is downloaded from the source. It is in semi-structured format, hence for easier manipulation and interpretation, it is converted into comma separated file. The output is then written in tabular format. You can see the structure of the CSV file, which consists of below attributes: customer ID, guest, seat class, success and description. Milestone 2 is metadata extraction and imputation. The primary objective of this milestone is to observe the pattern of distribution between each of the metadata field. Metadata can be extracted through the description field that is present in the dataset. The description attribute is in string format. It seems to be consisting of customer first name, customer last name, customer age, and customer gender. Customer age can be identified by the numbers that is present in the description field. Beside this, the gender can be identified by the salutation which is prefixed, that is like Mr., Miss and Mrs. So the extracted metadata then can be appended to the CSV file. This extraction is done using the split and apply function in Python. You can see the CSV file after the extraction is completed. So now it consists of 2 more fields, that is age and gender. Next step is data imputation. Most common class imputation method has been used for this activity. In this, the NaNs present in the attribute column name, gender, and age has been filled with the most common value used in the column. This functionality is achieved by fill NA and apply function in Python. Milestone 3 is metadata exploration. So in this step, we are performing initial data analysis. That is, we are doing some sort of visual exploration to understand what is in the data set and what are the characteristics of data. So in this, we are basically plotting the count plots, or we are observing the trend between the attribute of the data set. This is carried out by using the matplotlib and seaborn libraries in Python. So the first one is count plot of seat class. Here we have plotted number of customer traveling through each seat class. So in this bar graph, we can clearly see that customers are preferring seat class 3 over seat class 2 and seat class 1. The second one is fair distribution in accordance with the seat class. So basically in this box plot, we have plotted each seat class and the fair ranges of that particular seat class. So we can see that the seat class 1 is having a very high fair range as compared to seat class 3. Hence it explains the earlier graph that why passengers are preferring to travel by seat class 3 and not by seat class 1. Next is number of guests traveling with customer. In this bar plot, we have plotted the number of guests that are accompanying the customers. So we can see that customers generally prefer to travel by themselves or at most one passenger. You can see a sudden reduction of number of guests as it crosses the mark of 1. In next visualization, we are plotting success count against gender. We can clearly see in the stacked bar chart that the cancellation is much higher than compared to the successful travel. And it can also be seen that males are cancelling more air travel as compared to female. Fourth milestone is attribute preparation and engineering for preparing for mining algorithm. So in this step, we narrow down our focus to the metadata field. The goal is to identify the top two attributes. So there are two sub-processes in this process. First one is to convert the metadata file into ARF format, and the second one is data preprocessing. So the ARF file conversion can be achieved by ARF viewer in the Weka tool. So in this, we can convert the CSV file into the ARF format. Next is data preprocessing. So in this, the success attribute is converted from numerical to nominal. The next step is attribute selection. The main goal of this step is to determine top two attributes by using the tenfold cross validation method. This can be achieved by selecting select attribute tab in Weka. Infogain attribute eval is acting as the attribute evaluator while ranker is selected as the search method. Attribute selection mode is tenfold cross validation and the result evaluates all the attributes with top two attribute as gender and fair. In the next slide, you can see the screenshot from the Weka tool. So under the select attribute tab, the attribute evaluator is selected as Infogain attribute eval. The search method is ranker. Once you click on the start button, then the model is running. Once the model is completed its process, then you can see it has lined the attributes in the order gender, fair, seat class, guest, and age. So we can clearly see that gender and fair are the top two attributes. The fifth milestone is prediction modeling and visualization. In this step, we build classification model using decision tree and random forest method. With this, we also predict the accuracy of the model. We also generate ROC curve for the model using tenfold cross validation method. As you can see in the screenshot, we have implemented the decision tree model using Weka. So in the Weka screen, we have selected the select attribute tab under which we have selected the classify tab. Under the classifier, we have selected rep tree, which is decision tree. Beside this, we have selected the test option as cross validation and specified the fold as 10. Once you click on start, the decision tree model starts executing. The model executes with an accuracy of 80.4714% and has classified 717 instances correctly and 174 instances incorrectly. After implementing the model, the next step is to visualize the ROC curve. ROC curve is a probability plotting curve which plots false positive rate against false negative rate on the X and Y axis. A model is said to be working well if area under the curve is 1. So after implementing the decision tree model in the previous slide, now we are implementing the ROC curve for decision tree. We can clearly see in the screenshot that the area under the curve for decision tree model is 0.8376. After implementing decision tree model, now we have implemented the random forest model. So as you can see in the classified tab, we have selected the classifier as random forest. We have selected the test option as crossed validation and folds with 10. And then when we execute the model, it runs with an accuracy of 81.0325%. It has correctly classified 722 instances and it has incorrectly classified 169 instances. After implementing the random forest model in the previous slide, we have tried generating ROC curve for random forest. So in the screenshot, you can clearly see that area under the curve is 0.8559 for random forest. Now that we have generated decision tree and random forest model and also the ROC curve associated with the model, it's time to test the model. The testing is done by providing sample ARFF file which consists of 6 records. The model reevaluates the test data and predicts the success label for sample test data. This slide shows the predicted value of success label for the test data. Now we are trying to compare efficiency of both the model, that is random forest and decision tree. So the random forest model seems to be executing with an accuracy of 81.0325% and the decision tree seems to be executing with an accuracy of 80.4714%. The area under the curve for random forest is 0.8559 and for decision tree it's 0.8376. So by comparing the figures, it seems that random forest model is performing better as compared to the decision tree. After implementing all the milestone, we can finally conclude that the analysis has helped to predict if a customer will fly or will not fly with airline A. It also helped to learn about the customer behavior when it comes to travel by airline. The result would enable the advertising agent to develop customer demographic specific packages so that they can attract more and more number of customers. Furthermore, I have tried to derive some conclusions and meaningful insights from the milestone. Gender and fare are the two important attributes when you take into consideration the air travel. Also, people tend to travel more when the fare is less. Male seems to be cancelling more trips than female. Passengers prefer seat class 3 as the fare for seat class 3 is less. With this, I conclude my presentation. Thank you.